Hey guys, how is everything going? This is JSer. In this video, I'm going to take a look at 8 to 5 friends of appropriate ages. Some people will make friends request. The list of the ages is given at ages array, and the ages I is the age of ith person. Person A will not make friends request with person B. Okay, B is not equal to A if any of the following conditions are true. So age B is too small, or age B is bigger than A. So people will not make friend requests to people who have a larger age. Age B is bigger than 10 and age A is more than 100. Bigger than 100 and A is more than 100. So this one actually is containing this condition, right? So it's meaningless, I think. Otherwise, A will friend request B. Okay. Note that if A requests B, B does not necessarily request A, so people will not friend request themselves. Also, how many total friends requests are made? Well, just we can just calculate whether each pair would send friend requests or not, right? So the brute force, I think we could do brute force. About the input, an input is maximum was 20,000 people, and the ages will be from 1 to 120, so it's finite. Well, this is a very huge hint. We could start brute force. So how many pairs are there? Well, it's n minus 1 pair, right? So and we can this pair, but its direction, it's with the direction. So something like this. Because it's direction, we need to compare the twice, right? For each pair. No, it's not 2, because this is already direction. And this is not direction. This is without direction. This is direction. For the start will be n possibilities. For the end, well, n minus 1. Yeah. So this is the linear. So this is the time complexity actually. Let's just try. Okay. At first we will define should request. Okay. A helper function which is from and to. I suppose this is already done. I create a count initialized to 0 for I find all the pairs. If it's self, we need to skip. If not, we compare, right? So if should request ages I, ages j, we count. And finally, we return the count. So what issue should request? Just filter out these invalid cases. If 2 is more than 0, from plus should be times 7, return false. If 2 is bigger than from, return false, and finally we return true. So this, I think we're done. Is brute force solution? Yeah. I try submit. So it's technically in logic there's no problem, right? We're just doing what we're asked to. Of course, in TLE. Okay, it's too slow. So how can we improve? One condition here is that people will not send requests to people who have a bigger age. So that's gives us a hint that we could sort the array first, right? If we sort, we don't need to filter, we don't need to calculate for all the pairs. Like sort first, we do it descending, and just sort. So now how many pairs are there? Well, so from start it will be n, right? For the n, no, it should be n minus 1. If we start from the first index, plus n minus 2 plus to 1. So it should be n minus 1 times 2 divided by 2. So this would be cut down half of the comparison here, right? Well, so we start from 2. Here's the problem. If they are two edges are the same, we would send 2 requests. But now we just compare them only once, right? Yeah, this actually we need to do some change here. So I from 0 to previous one, and j will start from I plus 1 and to the end. Okay, if they're same, it's not, there's no case select here, so we just compare 2 edges. If they should request, then if edges and I, if they are the same, then we should pass 2 because there were 2 requests, right? If not, there will just be only 1. So this should also work, and slightly faster. Cool, we're accepted, and so it's twice as fast as the previous one with brute force. We sort first, and the time complexity actually doesn't change, but slightly better. It's like this. Okay, so it's actually still n to the square. Well, how could we improve more? Let's try to analyze our result, our example a little better. We're given a hint actually. The ages are 1 and 20, right? So rather than we compare each pair of ages, we can actually find the ranges. Like if the age, find the appropriate range for specific age. Like for 16, the range will be, like say, for 16, so it will be 8. So for 16, it should be bigger than 15, smaller than 16, something like this, right? Yeah, so it's actually 16 itself. It's 15 is too small, 17 is too big. So actually for each age, the range is limited, and age is finite, right? You said we got the ages from 1 to 200, so we could just do the counting, right? For the range of each age, right? This is what we get. Cool. So let's do it. So it should be better than this. So let's see what the time complexity would change. So now we traverse through all the ages. So it's linear time, and for each age, we will calculate it from. We will sum up the count from the minimum is. Oh, let's just try find the smallest one. Okay, so for 1, it should be what? Bigger than 7. Bigger than for 1, it should be bigger than 7.5. So it should be from 8 inclusive to 1. So this is 0, right? So 2 still is 2 should be bigger than 8. It should be 9. And 2 is a 0, right? So what's the age that 0.5 times x plus 7? This one should be smaller than x. So x should be 15. 15, right? Right? Is this right? It should be bigger than this one. And smaller than this. Yeah, x should be bigger than 14. Let's see what happens to 14. Well, 14 would be 14. So bigger than 14, it should be 15. And 14. No, so it's not still 0. So the age should start from 15. 15 is 7.5. 14. So 15 to 15. This is finally the first one. Yeah, the age must be at least 15 to have appropriate friend request. Okay, let's go to 100 to see what happens. 100 it is 57. So we're bigger than 57, so 58 to 100, right? Oh, the maximum should be 120. Let's see, if 120, it should be 67, 68 to 120, right? To itself. Yeah, so we could just do, wait a minute. We don't even to calculate for all the people. We could just count how many 15 for age 15. How many people are there? How many people are there? And for each of them, they are actually the same, right? So 15, they count and find the range count. So actually, the time. First, we will use linear time to count all the ages, and then count the range. Should be what it should be. Well, it's constant, right? Its maximum is 120. We just count. Yeah, so actually this should be linear time. Okay, wow, cool. Let's start. So the first step is count the ages. To loop through each age, and then count the range. Cool. Okay, now let's create the age count. New array, because it's from 1 to 120, so 100 to 121. A field 0. For that age of ages, age count age plus 1. So we got the count. Now we loop through each age and check the range, right? Here let's see the result. Set the result to 0, and then for not let the age, but for the minimum is from 15. So for let I equals 15, smaller than 221 plus. This is the age. So every range will contain itself, right? Cool. So now let appropriate age count equals 0 for let j equals math this should be ceiling, right? Ceiling I divided by z to 0.5 times I plus 7. This is the lower boundary. J is smaller than or equal to I, j plus plus. So we just sum them up, right? Appropriate count plus what do you would do? So age count j, right? It's like for 15, only 15, so we count 15 in. If 120, we will start from 68. No, we have a problem. Mass 4 plus 1 actually. Let's here plus 1. Right? If it's 15, it's 14, it's 14 here, plus 1 15. It's 15. It's still it's 14, 15. Cool. So this is right. Okay, plus them. For 120, we will start from 68 to 120, and we count all of them. And so for this age, there will be like this amount of appropriate ages in the list, right? So the total what would be? But this actually have this I counted, right? The I is in the range. We need to remove that. So I think we could start with -1. This could remove itself. And we will sum them up. Equals appropriate account times. Well, because the request is two-way, right? Like we got two-way. No, how many for I? There will be multiple I in it, right? About 3 people with the same age, 15, and the 3 will be counted here. So we sum them up, like 15 itself. So with 3, so it's 2. So for one guy, it will be two friend requests. So times age count I. Yeah. So that's how we get the result, and finally we return the result. I'm not sure this works. Let's review our code before we try. Okay, we fit a 0. Let age of, we count them up. See, like 16 got 2. Okay, now we start 0. We do from 15 to 120. Cool. Appropriate age -1. We start from 16. So 16 this is 15, so it's still 16 to 16, so it's 16 itself. Here 15, 16, 16, only one 16, so 3. So for 1 it's not 3, but okay, 2. So this is actually 2. 2 plus minus 1, 1. So for 1, it will be only one friend request. So 2 of them, 2 plus them. Oh, this should work. And this should be returning 3. Yeah. Okay. Cool. Now we're accepted, and a little faster than the previous one. Still, we're not doing so great. So, okay, for this one, it's actually, I think it should be linear time. Why we're so slow? I know we use a lot of memory. That's because when we are checking the age of 120, we definitely want to calculate the sum too, right? So this should be no problem. Problem maybe because you see we use a lot of memory. Let's try to improve it. We use array to do that. Maybe we could use a map, because map is better for sparse things with the, like, say 220,000 people. Doesn't cover all the age range, so using this for array will be a waste of time. Okay, if we say it's a new map, if has it, we set age get age plus 1. Now we set it to 1. Cool. So now we could just loop through the keys of the map, right? So the possible ages, it's not like 15, right? Okay, so for let age count of age count, the count should be like this. The J maps for age, but is more than an age. For count plus equals to age count get J. We have written the code from array to map. Let's try to see if it helps. Not a number. What? Okay, we use a map. If has my age, we set it to plus 1. If not, we set it to 1. Now we loop through the age and the count. Repeat it with minus 1. We start from age plus 7 plus 1. This one then age. And then we plus get J. Result. This actually looks good to me. Ah, God! I don't need to sort it first. I'm so stupid. I don't need to sort. Sort costs us a lot of time. Let's continue our using map. Map, okay. This looks good. These are 0, age count. J start from the range to the end. Get the J. What's the problem? 16, 16. good. But for this, we got some problem. Why? Okay, sorry, allow me to log the age and count. So yeah, this is right. Oh shit! Man, why I'm so stupid? They might not be. They might not exist. If you're using the array, we can initialize for all the count to 0. But now, yeah, we need to set the default value. Got wrong answer. Does this make a difference for? Okay, so log age count. Okay, we got S1 111, so 100 and 1. What's the problem? If this will return undefined, and if it's undefined, we set to 0, so it should be no problem. So j count. I think that because LeetCode doesn't support the double question mark, which is the what? It's cleanse. What is that? Noonish cleansing, right? Noonish cleansing mark. Is this right? Huh? Wait a minute. Oh, God. No, it's not about that. So, oh, why? What's the problem? It can't get J. Undefined. What? Okay. I'll try to say if has J. So log the pair, which is age and J. You get it? And of course we need to get this. So 188, we get 1 and then self 1. And 115, 1 and 1 and 1. So this actually is 0. This one is 1. This one is 2. This one itself. So it should be 3. So log age appropriate. So -1? I see what happened. So for 5, there's nothing, so we set it -1. So actually it will be plus, right? Yeah, I know what happens here. God, I'm so stupid. Okay, we plus it. Okay, I better set to 0 and count. So if we found something, but why 5 is -1? But what 5? 5 should have itself. 5 should have itself as the 5 -1. Ah. Yeah. Ah, shit. Yeah. Because before we use the array, we set the minimum to 15, right? But with the new map, there is no minimum of 15 something. So I'll say if age is more than 15, continue. I'm so stupid. There's cool. Now let's submit. Great, we are accepted, and still we're not that fast. What's the problem? Maybe it's because of this map is not that fast. Let's go back to the array approach, which is like this, but we remove the sort. Let's submit. Cool. Still we're not that fast. This now time is fast. All right, so that's all for this one. The age is finite. Give us a hint that we could actually count something like a bucket sort. We just count the amount of each age and do the direct access, right? Without doing the comparison. Let's try to see what other people is doing. Wow, approach 1 is counting. Cool. Uh-oh, and it's done. Yeah, we're doing actually the same. Actually, we're running better than it because it's start from 0 and do the check. But actually, we could do the minimum. It's like this, and ignore these checks, right? Yeah, I think we're doing great. Cool. That's all for this one. Hope it helps. See you next time. Bye bye.